Hello and welcome to the June 2021 CUPGRA Virtual Members Day. This is hopefully our final virtual event and we look forward to welcoming you back in the flesh on 27th of July. We're filming this on the 3rd of June and as you can see from the backdrop, we're a couple of weeks behind where we'd normally be, with the first plots reaching 50% emergence a couple of days ago. So we'll begin by summarising the season's weather so far in Cambridge and around the country. January was very wet, followed by an average February, which meant that soils were close to field capacity coming into March. So there was a lot of soil drying required before we could begin cultivations. April was exceptionally dry, which helped us dry out the soil, but then in May, after planting, we had 84 millimetres of rain, which made up for the lack of rainfall in April. Conditions here were relatively dry compared to other parts of the country, however, and in many regions there was more than 100 millimetres of rain in the first 3 weeks of May. Marc Allison is going to discuss the potential implications of this for nitrate leaching. Perhaps surprisingly here, our soil temperatures during April and May were slightly above the long-term average. Nationally, however, until last week, average air temperatures have been consistently below the long-term average throughout April and May, and this has led to delayed emergence and also slow canopy development in crops which have emerged. So this year we're in field 37 on the Narb Trials ground, which is a few hundred metres southwest from the Sophie Taylor building, much closer than the fields in 2018 and 2019, but a couple of fields over from last year. The soil type here is a sandy clay loam with 52% sand, 28% silt and 20% clay, which is slightly heavier than most of the land in 2020, but similar to the heavy parts used last year for the reference crop. The phosphate, potassium and magnesium indices are all index 3, so only nitrogen has been applied. And the organic matter content is slightly higher than last year's fields at 4.5% compared to 3% in 2020. The reference crop this year was planted on the 21st of April, which was the third latest in the last 20 years, but slightly earlier than in 2018. It's worth noting, however, that the earliest emerging reference crop in 2011 had a lower yield than the latest emerging crop in 2001, which didn't emerge until the 16th of June. Plots reached 50% emergence a couple of days ago, but this was mainly a consequence of the late planting date rather than low soil temperatures, and this date was very close to the expected date based off soil temperatures fed into David Furman's emergence calculator. If we were to use last year's soil temperatures, emergence was only expected to occur around 3 days earlier than this year.
I'm Marc Allison, and this afternoon I'm going to tell you a little bit more about the background to the field and also about the background to some of the experiments we're doing here. So as Simon has mentioned, we've got a fairly heavy textured soil here, and that's the basis of 2 spot points we've taken in this field early in the year. But one of the things that really came out of the work we did last year was the variability we see in soil texture within the field, and also very importantly within experiments. So to perhaps look at that in a bit more detail, we actually had Andy Binley from Lancaster University come here on the 23rd of March and take some electrical conductivity scans. Now, just to how you interpret these, so essentially high conductivity indicates a high water content, which is in turn correlated with a high clay content. So the higher conductivity is a proxy for high clay content. And as you can see, we've got a reasonable amount of variability in the field, and the whole field is on the left-hand side of the image. But also we've taken some detailed scans, which you can see on the right-hand side of that slide. And the importance of this is the variability is that that variation in soil texture we think may be correlated with differences in emergence rates, and that's what we found last year, and that's what we are looking at this year in a bit more detail. We've actually got some thermometers in the soil measuring soil temperature where we have different soil textures. So a bit more about background about the field. The rotation in this field is a typical sort of beans and cereals rotation. The farm record's a little bit vague about the last time we had potatoes in here, but it's well over 10 years ago, and the crop in 2020 was beans. We had the soils tested for PCN, and again, as you can see from the data slide, there is no evidence of PCN in this field. So in common with previous seasons, we actually established an oat cover crop before our potato crop. And we've been doing this since about 2018. And the PowerPoint slide you can see before you just shows a sort of summary of the yields of these cover crops from 2018 through to 2021. The 2021 cover crop gave a yield of about 2.5 tonnes a hectare, which is fairly typical to the ones we had in 2018 and 2020. We haven't got a nitrogen uptake value for the cover crop yet, but I would imagine it's going to be similar, somewhere between 50 and 60 kilograms of nitrogen per hectare. Now the point about the cover crops here is we're not really growing them to take up nitrogen, or that may be a benefit in actually reducing overwinter nitrate leaching. The main point while we're using them is to actually take up water from depth and actually aid cultivations in the spring. Previous work of mine on cover crops when I was working on sugar beet showed that for each tonne of cover crop dry matter, we actually remove about 20 millimetres of water. So in other words, a 2.5 tonne cover crop would take up about 50 millimetres of water from the soil profile. So the graph you can see is looking at volumetric water content against time, and the graph ends when we actually destroyed the cover crop. And the important point about this graph is it's not soil surface water, it's soil water at depth, at 25 centimetres, which is the depth that we cultivate at. And as you can see, over a period of time, it declines from almost field capacity when we first started measuring through to a considerably smaller amount. And that, as we can see, is the main benefits of using a cover crop, particularly on heavy land. And we'll come back to that a little bit later on. Just as we destroyed the oat cover crop in mid-April, we also took some soil samples and to do a VES assessment. Now, if you want more details about VES assessments, there's a link on this slide, and there's also the same link on the links that were sent out with for this series of presentations. So if we look at the VES assessment we did in 2021, it comes out in the mid-2s. That's not quite as good as we found in 2020, but it was better than what we found in 2019. And again, I think this is indicative of the fact that the cover crop actually has done some good in drawing the soil structure out, and we haven't ended up with some amorphous mass of soil which would not be fit for cultivation. The next slide shows the actual series of cultivations we use to establish the potato crop. And also in this video presentation, you also see some videos shot by one of our technicians, Elle, which shows the cultimer working to actually incorporate the cover crop and also the rotor ridging operation. So the cover crop was burnt off with glyphosate on the 13th of April. The following day we had the first pass of the cultimer at a roughly 25 centimetres depth. The day after we had another cultimer operation at about 2 inches deeper, 5 centimetres deeper. And then we had the rotor ridging the day after that. So the whole process of going from a cover crop into ridges we could plant happened in a relatively short period of time. As Simon has showed in the data table he presented, due to the quite high soil indices for P, K and Mg, we didn't apply any of those fertilisers to our strips. And also, because of the work we've done with AHDB on sulphur, we didn't actually apply any sulphur fertilisers either. For all the experiments that didn't have nitrogen as treatments, the average rate of nitrogen, overall rate, was 206 kilograms of nitrogen per hectare. So going into a bit more detail about the establishment of the CUPGRA reference crop, we started off with the ridges being drawn up. Then to actually spread the fertiliser, we actually knocked the ridges down, spread our fertiliser, and then had the experiment then re-ridged. We then planted into those ridges and then reformed the ridges by raking. So that's how we ended up with the ridges you see now.
We received a new grader in December, purchased with support from CUPGRA. It contains a 3-dimensional camera which measures the length, width and height of each tuber. From the width and height it calculates the tuber diameter, and from the 3 dimensions estimates individual tuber weights, but we will also record the total weight of the sample. As well as speeding up the process of grading, it should produce more consistent data by removing the human element from measuring tubers. Having data on the shape of each tuber will also allow us to investigate how tubers change shape as they develop, which will lead to improved seed rate recommendations and more accurate forecasts of tuber size and length. We've completed initial testing, but we'll be comparing the data generated from the old and new grader throughout the season.